Hello, my name is Louis Schauer, and this is my presentation on Physics 2211 Lab 4 Oscillations. First, let's take a look at some models and principles. This lab will be examining oscillations, and we're going to look at how kinetic energy and potential energy interact. We'll look at Newton's first and second laws and the momentum principle, and we'll be focusing on oscillatory motion. We're going to use GlowScript and Tracker as our main methods for tracking data as well as making the model. GlowScript will be used to create the online physics model. Here are some results. This is an image of the final model I created, as well as the X and Y position versus predicted data, and a screenshot of my data from Tracker. And here's a video. Alright, now we'll go over some physics equations and ideas. We have the kinetic energy equation, K equals 1/2 mv squared. This relates the kinetic energy to motion parameters, mass and velocity. We have the force of gravity equation, which will be in the y direction. It accelerates downwards with constant acceleration, 9.8 meters per second squared. We have the delta E equation, which connects the total energy to spring, potential, and kinetic energies. And for some assumptions, we're assuming that there's no motion in the z direction, and that we're assuming the spring is perfect, so there's no internal friction loss. Calculations and preparation. Most of the calculations I did were to find the kinetic energy, potential energy, spring potential energy, and then obviously the energy is given using the formula we got in the last slide. And then the other preparation I did was calibrating the tracker online with the video clip presented. And here are some more screenshots of my code if you'd like to take a look at them. And here's some comparisons, analysis, and limitations. Here's an image of the predicted versus actual X and Y motion as we got from Tracker and WebVPython. I would say that the model was generally successful, and then the model motion matched up relatively closely with the real motion as seen in the video. The model does not take into account energy loss from internal friction of the spring, and there may be a small input error from the spreadsheet that's also causing some of the variation in the data. And I've showed most of the result photos that I'd like to show. And for the extension questions, for your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. Yes, the energy principle is satisfied. The potential energies and the kinetic energy add up to the total energy without any energy being created or destroyed. I think that there's obviously something wrong with the image, but if you zoom in really close, you can see that they all add up. Using the data you obtain in Tracker, make two separate periods. First, by estimating the period of oscillation from the X position data, and second, by estimating the period of oscillation from the Y position data. Compare the two estimates and discuss. So using the Tracker data, I said that using the X position data, I would estimate the period to be roughly 1.5 seconds, and using the Y data, I would estimate the period to be roughly 1.6 seconds, showing some slight variation in my data. Thank you.